Congratulations, class, on being done with Chapter 8. It's one of the chapters that I think is one of the hardest, and as you can see, it doesn't have necessarily the hardest math in it, but you have to memorize all the properties and you have to be able to apply those properties. Please don't forget those properties because they're going to come back on the final exam. The next section talks about area and perimeter of different shapes. Hopefully we all remember perimeter of a square would just be adding all the sides together. Anything around the outside, around the outside, around the outside. Anyway, so area is different. It's not the outside, but it's how many one by one squares can fit inside a shape. So for example, if I wanted to find the area of this bigger square, I would see how many little squares are needed to go inside this. So we could take a good guess. Obviously, it looks like almost 3 would fit across, and it would look like 3 fit down. So if we filled in, it would be 3 by 3. That's area. So area is like painting a wall. How many square feet? Area has no depth to it, so it is flat. Let's look at this one. What's the area of this rectangle? So basically I'm asking how many squares fit inside it, and the squares have to be 1 by 1, whatever you're dealing with. If you're measuring in square feet, then it's 1 by 1 square, a foot by a foot. If you're measuring in centimeters, it's 1 centimeter by 1 centimeter. So obviously I can get 4 of these across. Looks like I can get 3 of these down. So if I obviously had to fill in, 4 times 3 would be 12 square units, whatever I'm dealing with. So there's 4 across here, and then there's 4 across the bottom. So that's 12 square units. So that's a rectangle. Same goes for a square, but area in any shape is how many 1 by 1 square or units fit inside it. So what's the area of this rectangle? 4 times 3 and 12. So we probably remember. This starts your note sheet. So the area of a rectangle, and here's the thing, guys, you're going to be given your formula sheet for this entire chapter. I'm just going through these notes to kind of remind you of why the formulas are the way they are. So a rectangle, as we already know, is base B, height H, which equals base times height. Please be careful when you're dealing with area formulas. You want to use lowercase letters for both B and H. Please remember the height. If you're using height in an equation, that it always has to be perpendicular to the other side. So of course, my first example, I give you the height because here's the perpendicular symbol. Here's the height of 12, but it's got to go to this base, in which I don't have. So the first thing I'm going to do, no matter what I'm finding, perimeter or area, I need this side of the triangle. So what are we going to use? Pythagorean theorem. We're going to say 12 squared plus x squared equals 20 squared. We're going to solve. Go ahead and solve, and you're going to get that x comes out to be 16. So now I know this side of my rectangle, 16. So if I need to find perimeter first, then it's simply 16 plus 16 plus 12 plus 12, and my perimeter would be 56. Area, formula equals base times height, 12 times 16, and it's 192. Now, please be careful if we're doing area, it's units squared. So here I don't give you units as centimeters or inches, but you would need to put units squared. And perimeter is just units. So if it was feet, perimeter would just be feet, and then area would be 192 feet squared. Let's go right to the triangle. Here we still have a rectangle. The height and the base would be perpendicular in the rectangle, so there should be 90 degrees down here. And what's ironic, to find a triangle, all I need to do is take away half of the rectangle. So if the rectangle's formula is base times height, then a triangle's formula is 1/2 base times height, which would equal 1/2, oops, sorry, BH. And you don't really even need the B and H, okay? So the formula for a rectangle is 1/2 BH. Since it's all multiplication, it does not matter if you multiply the base times the height and then you divide by 2. It doesn't matter if you take half of what the base is and then multiply it by height. It doesn't matter if you take half the height and multiply it by base. So it does not matter. Let's look at triangles, because the thing with the triangles, if you recall when we did altitude a while back, that the altitude can lie in 3 different spots in the triangle. So in this obtuse triangle here, the altitude is inside the triangle. So which one would be the altitude? BD. And which one would be the base? Because the altitude has to be perpendicular to the base. So the base would be AC. In a right triangle, do you remember which one's the base and the height? Your height, which is your altitude, in this case, we could call AB. And then our base is what it has to be perpendicular to, so it's BC. They're interchangeable in a right triangle, but what you have to understand is in any right triangle, you are always using the legs as your base and height. And then remember the triangle, most likely the obtuse triangle, in which the altitude lies outside the triangle. So our altitude is very easy. It's CD. It's the dotted line that's going to be outside. But if you're multiplying to find the area, you have to be careful. You're just multiplying by the base of the triangle. And in this case, AC is your base. You do not multiply anything with this AD piece. I know you think you want it, but you're just finding the area of the yellow triangle. So it's only the bottom, AB, and then the altitude that goes with it. So let's look at our first example. I want to find the area of the largest triangle in this picture. So not this right triangle, not this right triangle, but yet this big gray triangle. So obviously there's a height and a base, and that's where there has to be a 90 degrees. So if the 90 degrees is here, this is our height, and the entire thing's our base. So we have the base, we know, hopefully. You know the base is how much? 36. And we need the height. Well, I don't have the height, but I have a right triangle right here, and I have a hypotenuse, and I have a leg. So the first thing I'm going to do is Pythagorean theorem. So I'm going to take 6 squared plus x squared equals 10 squared. Go ahead, solve. X is 8. Pause it if you need to write it down. So that gives me that this piece here is 8. Now that gives me my height and my base. So I have enough to use my formula, which is 1/2 base times height, and therefore I can just do plug in 1/2 of 36 times 8. It does not matter if you multiply 36 times 8 and take half. It doesn't matter if you take half of 36 and then multiply by 8. Doesn't matter if you take half of 8, which is 4, and multiply it by 36, and our final answer is 144 units squared. And if I forget units, you can literally write it as units squared, and that would be my answer. I'm going to try to make sure that I have feet, inches, centimeters, millimeters, some sort of unit on a test or quiz. Let's look at our next example. Very textbook-like. This is right out of your textbook. I give you the hypotenuse. I give you a leg. I tell you it's a right triangle. Obviously, it's a right triangle because it gives you a hypotenuse. So I want to find the area. First thing is, you need what in order to find the area of a right triangle? you need both legs. So we're going to do Pythagorean theorem. Give you the leg, give you the hypotenuse, go ahead and do Pythagorean theorem, and you come out with x is 45. You might want to double check my work. Sometimes I do it fast. I asked you to find the area. The area is 1/2 the base times the height. I know that the base is 24. The height is our new number, 45. Base and height are interchangeable. Does not matter. So 1/2 of 45 times 24. So it's 540. And since this has units, it's feet squared. So my final answer would be 540 feet squared. I just read that it asked for perimeter. And so if you thought about your triangle, it's a right triangle. I would have 51 plus 24 plus 45. And the perimeter would be, that's 120 feet. And so the big thing you got to remember is that area is feet squared, inches squared, units squared. And that perimeter is just feet. It's around the outside. How much did you go around? If we look at this problem, it's a problem in which I give you the area, I give you a value for the height, but you need to find x, and I give you the base. So we're going to start with our formula. Area equals 1/2 base times height. So I'm going to take 276, which is the area, set it equal to 1/2 base 23 times height. Now again, this is all multiplication. It doesn't matter that this has x. So I would first just multiply this out. You could multiply 2 to the other side, but I would just make it one big number. 1/2 times 6 is 3. 3 times 23 is 69. So 276 equals 69x. Divide x is 4. We have one more shape. Our last shape that we're going to learn today is a parallelogram. If you look at this quickly, a parallelogram kind of has two bases. So it has a base along the side and it has a base along the top. The problem is, to do a parallelogram, you still need the actual height. And if you look at this, if I take this and put it over here, what did I just make? A rectangle. So the area of a parallelogram is exactly the same as a rectangle, and this is why, because it is basically a rectangle, it's just slanted. The problem is you have to remember to use the actual height, the one that is perpendicular to the specific base. So right here, base B, h height, and so B times h is your formula. The first example I give you, a parallelogram has an area of 133 and a height of 19. So what would the base be? If we look at this, if we do area equals base times height, we take 133 equals base 19 times height x, and we say that the answer x is 7. Since the area was in square feet, my final answer is 7 feet. So there basically are three shapes out of chapter 11, section 1. The other thing the textbook talks about is a square. It's not on your note sheet, but the only thing you've got to realize is on your formula sheet that you'll be using, instead of saying base times height, which is what you can use for a square, since a square is a rectangle. So it's absolutely fine to use that, but it might list the area as s squared, because in a square, the sides are all the same. So if you had base times your height, it would be s and s would be the same, or x and x, so it would be x times x, which is x squared, or s times s, which is s squared. So you're going to be able to use your formula on the entire chapter. Don't lose your formula sheet, otherwise your job to get a new one from somebody else. So you just got to be aware of what I give you and how to find it. All right, thanks. Have a good day.